All right, so in this video, what I'm going to do is I'm just going to show you correlation. Okay, so this is day two notes. This is wrapped up with day one, so we're kind of putting the two lessons together. But this is just going to be a video on correlation. There's not necessarily much more to add other than correlation to day one's notes other than correlation. So I just thought I'd do a video walking you through it. So first thing is correlation is a measure of the strength and direction of a linear association between two numerical variables. So in day one notes, we talked about scatter plots, how to graph a scatter plot both by hand and on your calculator. And what we noticed was that there is sometimes a correlation between these two numerical variables. So the first thing we want to do is we're going to go over a little bit of vocab, okay? So to quantify the strength of a linear association between two numerical variables, we can use a stat called the correlation. And correlation is often described as R, just an R value. We almost always use technology to calculate that correlation. There is a formula for it, but we're never going to use that. We're just going to use the calculator because it's quicker. So a little bit of vocab. The values of R fall between -1 and +1. Okay, and it can be -1 and it can be +1. That's inclusive. So if the association is negative, so if there's a negative association, then R will be less than 0. If there's a positive, then R will be greater than 0. And if it is equal to 0, then there is absolutely no correlation between the two numerical variables. Now, if R is equal to 1 or equal to -1, then your dots on your graph will fall in a perfectly straight line. So let's just look at a couple examples here. I've got some graphs that show some data from the 2008 NFL season. Now the first one, rushing attempts and rushing yards. So you can see that there is a positive association, positive linear association between these two numerical variables. So the R value for this one is positive 0.89. So that's pretty close to 0. So that's a fairly strong correlation. And then right here we got passing rate and rushing rate. This one's a negative association because it goes down in a negative line. And it's even closer to a straight line. So its R value is negative 0.97. So that's even closer to a straight line than this one is. So the closer to 1 or -1 you are, the more straight of a line the dots will form. So an example of one that really isn't any correlation, let's look down here in the bottom right. We've got passing yards allowed and points scored. So you can see these dots are really scattered out. There's really not much going on in terms of correlation, and the R value will show that. R value of negative 0.04, that's almost 0, right? So there's really no correlation between passing yards allowed and points scored. Now I do want to say this real quick. I'm going to jump ahead a little bit. Caution, correlation does not imply cause and effect. So just because there is a correlation, a strong correlation, like an example, let's go back a second. Just because rush rate and pass rate have a strong correlation, that does not mean that one causes the other. Okay, and I got a couple of examples here I'm going to show you. So if I look at these graphs, so this website shows us some graphs of weird correlation. Okay. So one of the examples is total revenue generated by arcades correlates with computer science doctorates awarded in the US. And it has a correlation value of 0.985. So that's a really strong correlation, right? That's almost a straight line. But if you think about it, does revenue generated by arcades, do you really think that correlates? Do you think that causes computer science doctorates awarded in the US to go up? So for example, if we spend more money on arcades, if correlation does imply cause and effect, then if we were to increase the amount of money that we generate by arcades, that means that we're going to get more computer science doctorates awarded in the US, right? No. Just because one correlates to the other does not mean that if one goes up, the other goes up. If one goes down, the other goes down. This is just a funny example of how two random things could correlate with one another, but that does not mean they cause one or the other. Okay, so I'm going to go back to the notes. Whoops. Okay, here we go. There we go. All right. So in order to, well, actually, let's just go through the notes here. I've got 2009, 2010 LA Lakers. Table shows the total number of personal fouls and total number of points scored for each member of the LA Lakers basketball team. And so I've got a table here showing each of the players, the number of fouls they made, and the number of points they scored. And part A asks us to make a scatter plot for these data using fouls as the explanatory variable and describe what you see. So we're going to use what we learned from day one notes to be able to do this. So first thing I want to do, I'm going to put these values in a table. So I'm going to hit stat, edit, and I've got fouls in list 1 and points in list 2. So I'm going to give you a moment, fill this out on your own calculator, and then we'll come back. All right, so what I want to do in order to graph this, okay? Sorry about that, but in order to graph this, okay, so we've got fouls in list 1, points in list 2, and so what I want to do in order to record it is I'm going to hit second y equals, and then I've got plot 1, I'm going to hit enter, and then make sure it's on, and then for the type, it's the first type, your X list is list 1, your Y list is list 2, and then we're going to hit zoom, and then 9. And then right here, we've got our graph. And so if I look down, I've got my graph right here, okay? And it's asking us to describe what we see. So this is stuff that we did in day one notes, but we can see that there is a strong positive linear association between fouls and points scored. Kobe seems to be out of the pattern because his point total is much higher than expected based on his number of fouls. So you can see right here, we've got a strong positive linear association. So the graph is going from bottom left to top right, so up in a positive direction, and the dots are fairly close together. So that means that our correlation is probably going to be pretty high. And when we say pretty high, we mean close to +1, okay? And then Kobe's way up here because he has a lot more points than fouls related to his fouls based on the other players. So part B, it tells us calculate and interpret the correlation between the points and fouls. So if I go back to my data, stat edit, I've got my list 1 and list 2. In order to calculate the correlation, what we're going to do is we're going to hit stat, go over to calc, and then we're going to go down to option 8. So option 8 says linear regression A plus BX. So option 8, hit enter. X list is going to be list 1, Y list is list 2, and then the other stuff you can just leave alone, and I'm going to hit calculate. So if I hit calculate, it's going to tell me R at the very bottom. So R equals 0.766, and it keeps going. So I'm just going to round that to 0.77. So if I look at part B, we can say the correlation is 0.77, and then that confirms that there is a strong positive correlation between fouls and points. Points scored, since R is closer to +1 than 0. So earlier, just by looking at the graph, we said, okay, this seems like a strong positive correlation, and our R value proves that. Since R is 0.77, that's pretty close to 0, we can say, okay, so there is a strong positive linear correlation between these two things, fouls and points scored. Now, based on your previous answers, should Coach Phil Jackson insist that low-scoring Luke Walton, here we go, low-scoring Luke Walton commit more fouls in an effort to increase his point production? If not, how might you explain this the strong correlation between these variables? So, as a coach, should you tell your players, hey, you need to foul more, that's going to make us score more? No, right? I mean, that doesn't make sense. You don't want your players to foul. But what is the reasoning behind this strong correlation? Is it fouls? Is the reason that people are scoring more because they foul more? No, the reason is more likely because of time. So if we look at our answer here, so no, even if there is a strong correlation between two variables, we cannot necessarily conclude that changes in one variable will cause changes in the other. Committing more fouls probably won't cause a player to score more points. The strong correlation is explained by playing time. So if we look at this graph, I mean, Kobe is going to be playing a lot more than some other players. I mean, he's a really good player. So just because he scores a lot of points, that doesn't mean that the reason he scores a bunch of points is because he fouls a lot. Chances are it's because he's playing a lot. I mean, someone like Luke Walton, he only has 19 fouls and 69 points. It's probably because he doesn't play as much as Kobe. The more time you have on the court, the more likely you are to foul, and the more likely you are to score points. So that just brings me back to my original point of just because there is a correlation, it does not imply cause and effect.